Chris Chinnock for Insight Media, CES 2023. Just met with LG Display. They had a private meeting room where I'm not allowed to make any photographs, so I'm going to have to tell you what I saw from my notes. So first of all, they were doing multiple comparisons between their white OLEDs and the QD-OLEDs that Samsung Display makes. Not surprisingly, they were able to show many flaws. And of course, Samsung Electronics, Samsung Display also tried to point out the flaws of LG's white OLED. So this is the LG's side of the story. So one of the first demos that they set up was a comparison between mini-LED LCD display, the white OLED, and the QD-OLED display. They showed several pieces of content and made the point that the mini-LED LCDs show blooming and lack of color accuracy. The second point of the white OLED compared to the QD OLED is in dark scenes, dark luminance scenes. There's a red color will be accurately portrayed in the white OLED, but it shifts to greenish in the QD OLED. And finally, another key point they wanted to make was that when you have any kind of ambient illumination, you're going to activate those QD materials, and it brings up the black levels significantly and can change some of the colors as well. So they say the reason for that is the lack of a polarizer. Now they were showing this with kind of side lights illuminating it from about maybe 12 inches away. I asked if the same effect would happen if the room lights were on. They said yes. I'm a little bit skeptical about that, however. They said part of the reason for that shift from in the low luminance ones to the green is because they use a dithering algorithm. That could well be. That's probably a real effect. But they said that the black luminance level in a 500 lux environment for the QD OLED rises. In a black room, it's essentially the same as the white OLED, but with a 500 lux ambient, it'll rise to 0.5 nits, and in a 1,000 lux ambient, it goes to 1.5 nits. So that is a pretty significant bump in the black level, if that is accurate. Again, that was done with a side light, so I'm not sure if that would be correct with an overhead light. They then moved to some of the new technologies that LG Display has developed, and they showed now the current G2 model of the white OLED, what's coming out in G3, which is going to be the 23 models, which has the microlens array, and they showed kind of a fourth generation, what will be a G4, which is the microlens array plus their Meta technology, Meta Boost. So the Meta Boost is basically an algorithm that helps increase the brightness. Today, it's limited to boosting brightnesses of about 25% APL over the screen. For next year's model, they'll be able to boost the brightness at any APL level, and they showed that in a demo as well. I asked about the microlens arrays. There are 42.4 billion of those lenses in I think there was a 55 or 65-inch display. And that works out to about 5,000 of those microlenses per pixel. They had some close-ups showing that, and even at the sub-pixel level, there are, I don't know if about 5,000, but there were certainly hundreds of them over the sub-pixel. I asked about the size of those and was told they are on the order of about 10 microns in diameter, and that can be done. It's a photolithographic process, and the Canon photolithography machines can support that level of resolution, I was told. So that's actually pretty interesting because you get from that not only a 60% boost in luminance, but you get a 30% boost in the viewing angle as well. So pretty major advancements. Let's see. So in terms of the kind of the G4 technologies that will be available next year in 2024, the MLA, the microlens array, plus the Meta Boost will take the what will be this year's G3 from 2,100 nits to about 3,000 nits for, I presume that's full white, and it will. I guess the Meta 2 itself will actually boost it from 700 to 1,500 nits. I guess my notes be a little confused on that one. They also had a demo of a 98-inch mini LCD. They didn't say the brand, but it was Samsung was the implication there, versus their 97-inch EX white OLED. And the demo here was to show that while the higher luminance, while the Samsung, the mini LED has higher luminance, it is also less color accurate in some scenes, as they were able to show. They also did a motion test, and because of the very fast response of OLED, it's not surprising that the mini LED did not perform as well in the motion test. That is it for the TVs. They also gave us a tour of monitors. I'll talk about that separately.